Right, in this video I'm going to show how quick and easy it is to make a 4-port threaded manifold which is used on compressors or water applications, and how quick and easy it is to make it on the lathe without any milling operation. And I've made many of these manifolds on the Chinese mini lathe, but today I'm going to show it being made on the Manifold ML7. I'm using a piece of aluminium which is 35mm in diameter and 35mm long, and the grade is T6082T6, so it's an actual good grade to use and nice to machine. Right, I've just faced off and centered, and now I'm going to be drilling a core diameter, and that's for the 1/4 inch BSP thread. Well, I'd just like to mention that especially if you're new to machining, if you're making compressor components or anything that's going to take high pressure, you want the thread sizes to be as near as possible. Now, when you're using drills on a lathe or even on a bench drill, you'll find that they tend to cut oversize even when they're new. So the most accurate way of getting the core diameter exact on a lathe or any other hole would be to drill undersize and use a reamer or bore it out. But in this instance, you don't need to do that. To get the thread or the core diameter as near as possible, you use a pilot drill, and I always use a pilot drill on a lathe anyway because it takes the pressure off the lathe and makes drilling much easier. So to choose the pilot drill for whatever finished drill size you're using, choose one that is just a bit bigger in diameter than the thickness of the web on the drill. It doesn't have to be spot on, just any drill around that size. You don't want to go too big with a pilot drill, especially for bigger drills, otherwise when they pick up they vibrate a lot. So that's the pilot drill through, and now the core diameter for a 1/4 inch BSP thread. If you're new to machining, you want one of these for the workshop. It's a Zeus precision book. Data charts, reference tables for drawing office, tool room and workshop. It's the best little book you can have in the workshop. Choose the BSP or British Standard Pipe Thread Chart, 1/4 inch BSP, core diameter 0.451. So you want to drill as near to that size as you can. And in this case I've got a 29/64 inch drill. Next it's the 1/4 inch BSP tap, and I've chosen a tap with a good lead in, so it's the starting tap. And for aluminium I just use a very thin oil like WD-40, just a shot of that. And I'm using my mandrel handle at the back, and start the threads off. And it doesn't matter how far you go down, because you can actually finish them off in the vise. So that's got a few threads on it, and I'll put that in soft jaws in the vise and finish it off later. And then it's just a quick deburr with a file. And you'll notice that I didn't put a chamfer on the BSP thread hole, and I'll show you why later. I deburr that by hand, but there's a very good reason that I didn't do that. And then it's turn round and face off and do the other end. So that's 2 ports done. So now I'm going to machine the 3rd port in the side here, and obviously need to change to a 4-jaw chuck. But because I'm only doing 1 hole, I don't want to change the chuck because it's too much bother. So I'll change over to the 4-jaw chuck using my special adapted back plate. I've got these chucks like this with a back plate machined with a spigot on there, and these can actually be held in the 3-jaw chuck, and it's perfectly safe to do that if you're experienced. If you are new to machining, it is obviously best to change over to the 4-jaw chuck on the actual machine. And I use one of these on the mini lathe as well if I only have, say, 1 hole to do. Obviously if there's batch work to do, it's best to change the actual chuck. Next I make a felt tip mark in the centre, because I want my ports all in the centre of the actual component, and I put that one in the independent 4-jaw chuck. You'll notice that I have 1 set of jaws round one way and the other 2 round the other way, and then this one goes in there like that, and just lightly tighten that up. I've centered this one up a bit already. To get it so that the center drill goes down dead on center of the diameter, you can actually use a center drill to center it up one way first, and then put it up right like that. Put the ruler or a piece of metal which is about 1 mm, 2 mm thick, and just bring the center drill down on that diameter, and you can actually get a rough guide to see whether that's square or not. If not, just push it over and test again. If it tilts one way, you'll know which way to push the jaw over, and then tighten those up. Those ones lightly first, and this one nice and tight. And because I'm having my hole or port in the center there and the center of the diameter, I can actually do the drilling first before any facing, and it's much better to do that because there's less force on the work when you actually do the facing off. And when using the 4-jaw chuck like this, especially held within the 3-jaw chuck, make sure that you have the revs are about 500 or below. This side here I'm doing the 1/4 inch BSP again. my handle again and just start those threads off. And it's basically just start the threads off so they're nice and square, and then you can actually finish off in the vise. And if you're doing this chuck holding method, it's best to use a saddle stop for doing the facing off. And doing this, I'm using a 45 ground tool in HSS. You could face off and have a complete flat right the way across, but I'm going to just go into the bore slightly and face outwards so that it can take the 1/4 inch BSP union and the Doughty seal, so I only have to clear enough for that. So just touch on the front face there, put the saddle stop up there and lock that up. And rather than using the compound slide, I leave that one locked so it's much firmer. I use my saddle stop with the adjustment to allow it to go in to take fine cuts. Allow it to go in roughly about 10 thou. And you continue machining like that until you have enough land so it clears the diameter of the Doughty seal, or like I say, you can actually just face the whole lot off so it's flat right the way across, but you must check that you have that actual diameter. And you need a reasonably good finish, and machining like this with the stop, allowing it to go in like that each time, there's no way that you can actually crash the tool into the component. So that one's done. And I've made many where I just face right the way across. That's a good method as well, because if you ever get any damage on the face here where the seal goes, you can actually put it on a piece of wet and dry and just rub it backwards and forwards a few times until you get a good finish again. But I'm doing this one purposely like this because I'm going to hold again in 3 jaws to finish off the faces, and it makes it easier having the full diameter. And just remember, if you're doing that operation, to leave it in the 4-jaw chuck until the end is complete, and that way the face of the or the face there will be square with the actual bore. So next I put the 1/4 inch BSP tap in those first few threads that I've just tapped, and put it into the vise with some soft jaws, and just finish cutting that thread. And that port's finished. Now for the final port, I'm going to use the 3-jaw chuck again. And I have what I call a second op adapter. I make loads of these for all different thread sizes. This is just a piece of mild steel bar, threaded one end halfway through for the 1/4 inch BSP union, and screw one of those in nice and tight. And the other end is 1/8 BSP screwed in there nice and tight. And you can use these adapters for various different like second op work. And like I say, I've got loads of different types in metric, BSP, or whatever thread I'm using. So this one simply goes in the 3-jaw chuck. Do it nice and tight. And make sure the union is nice and tight in that adapter. And then the port that I've just drilled and threaded just screws down onto that one right up to the face. And you can actually just screw another component into those other threads that I've just done, like that, and just give it a nice tighten up. Then you know that when you machine this end, it's going to be dead square to the other end. Not that that matters, because they're all independent ports. And in this side I'm going to do a 1/8 BSP thread for a port for the pressure gauge. core diameter for the 1/8 BSP thread, which is about 8.5mm. The 1/8 BSP tap, and then the face. And again, just check with the union and the Doughty seal that there will be enough land for that seal to fully connect, and that one looks fine. So next, undo that one. And then it's a case of putting it back in the 3-jaw chuck, and this is why I didn't have the flats all the way across. Well, I mean, you could get away with it all right like that, but I've got the full diameter just to hold on again and face off the marks that were left by the 4-jaw chuck. a very tiny chamfer on the BSP thread hole. Turn around. You want a fairly good finish for the Lathe seal. And a very tiny chamfer on that thread. Then it's a case of just holding that in the vise again and just finishing off those two ports there with the 1/4 BSP tap. So that's the finished component, and the reason you don't have a very big chamfer on any of these ports is because there's a very narrow limit for that Lathe seal to land on. And often when you buy manifolds like these ones here, they've got a very big chamfer on there like that, and when the Lathe seal goes down onto that, in some instances it actually won't seal because of that chamfer. So it's best to have the least as possible, just basically break edge and deburr. And then the Lathe seal goes on the union like that, screws in and locks up, and you can obviously use whatever component you want on there. This is a tail end one for connecting a pipe, and you'd use PTFE tape on that tapered thread and screw that into maybe that port there. This is the 1/8 BSP thread that I made for my clock, and that one again you use PTFE tape on that to seal that one up. And also, having PTFE tape on like that, you can actually turn it to whatever position you want when it goes tight. I like that one there. And then that's a Euro fitting, like the PCL. I do like the PCL fittings better, but this is the Euro one, and that's got a tapered thread, and maybe you want to put that in that port there. So that's the finished 4-port compressor manifold, and also the same manifold that I used on my water cannon. So like I say, they're very easy to make up and very quick. And obviously you can make them to whatever size you want. You can make them with 6, 7 or 8 ports or whatever you choose. You can make them out of brass and stainless steel. Ones like this, when I worked in the aerospace industry, I did test and assembly and gained most of my knowledge of components like this from there. A component like this with 1/4" BSP threads we often had for test adapters, and had them up to 6,000 psi when testing hydraulic equipment. And when you fit these to a compressor, sometimes you'll have a problem when you screw them down that they won't face in the right direction. There's a special union fitting for those 1/4" BSP or 1/8 BSP. I think you can get bigger sizes as well. So that one would screw into the compressor with the Lathe seal or whatever, and it's got an end in there which will seal on the cone of the ordinary male union. So you'd screw that one on like that, and then position it to where you want, and then lock that one up to seal. So there's all different components, loads of different hydraulic fittings to make really good compressors or water cannons or whatever you're making. And just before I go, this is one silent compressor that I'm just making up at the moment. I showed the tank the other day in my last video. This is the fridge compressor resprayed, and this is a tank off of a old small noisy compressor which was 90 decibels. This one's obviously silent. I've made components up to replace the oil in it and to put hoses on or whatever, and I'm just waiting for the pressure switch and various other components to finish this one off.